This conference will now be recorded.
Hi guys. So were you able to actually play with your Azure account? Were you able to create your own Azure account? Rohit, Richa?
Oh no, not yet.
Not yet.
Yeah, we logged in.
Sorry, you logged in, Rohit?
Yeah.
Okay, that's good. Okay, let's start. So today what we're going to discuss? We're going to discuss basics of virtual networking. So do you know anything about IP address space? Guys, do you know anything about private net, what is it called, a private IP address? What is your public IP address? And basic differences between the both. What is this 192.168.1.1? Any idea?
No, Abdul.
Okay. So let me just open some. Okay. Yes. Now, you see, this is basically how our devices in the network communicate. Okay. So the chart diagram gives complete overall picture. So internet is nothing but connection of several routers across the world. So if you want internet, you need to have a router. This router is used to communicate with other routers and send your information packets across routers to the destination. Okay, How they are connected? They are connected using internet service providers. So internet service providers, how they so let's say an area is actually served by an internet service provider for the network. So if you think in India, it would be ACT, it would be your cable, or might be Hathway, famous internet service providers. So they are handful in any country. There might not be more than, let's say, a couple, maybe 6 or 7, sometimes maybe not more than 10, because it's a very tight space. So a lot of competition is there, so it's very hard to survive as well. So in this internet service provider space, you would be buying a bandwidth, and you use this bandwidth by your network. So you will put the lane, a wide connection lane from the end customer. Okay, that is here. Okay, these are your phones. Okay, now this is your home router. So it actually uses a wide area network IP addressing scheme, and it will connect to your router via a wide connection. From there, this ISP will communicate. All ISPs will communicate with each other. Okay, that means you will have the public space. From ISP, all your packets will go to internet. Now, if you just understand this, internet is nothing but connection of routers. One router is connecting via ISP. Each router is connecting via ISPs, or a bunch of them clubbed and connected via ISPs. Now, this is whatever you get internet inside your home. That means when you switch on the router, you will get an IP address for your device. If you connect your phone device to your router, then you will be having a device information. So this connection is basically is called private IP. That means this uses a private IP scheme. That means if you take any router, the IP address scheming will be same. It will start with 192.168.1.1 or 1.2 or 3. Okay, what is this basically means? That means,
Abdul,
yeah.
we can't see your screen.
Oh shit! I'm so sorry.
It's okay.
I time to time forget that. You see? So let me repeat this. This is basically the schematic diagram of your router or your network that happens in our day-to-day life. You have all your phones or your electrical, your particular devices which has network features. So example, phone. Your phone want to connect to your router. Okay, this is called local area network. We call it LA. Yeah. Local area network means these are all actually local to private spacing. That means you can't give the IP address of your phone to an external party and think that the packet will reach you. It won't. This IP address is strictly local. That means you can't use your IP address of your phone, but instead, okay, all packets which are communicating here in your network or here in your local home network will have to go through the router. The router will have a public IP that is called a wide area network IP. So this is a public IP, and if you give your IP address, your router's IP address, then that could be used to actually take the information and give the, receive the information. So this is actually called as a public IP. And with the help of public IPs, a large collection of routers, they connect via your ISP provider. Your ISP provider basically has all the required servers and everything. Okay, and he would be able to communicate to other internet services which are stated in different countries. So you need to understand this whole flow. So this is very important. Public IP space is this one, okay, and this is a private IP space. Okay, so if you see IP addressing scheme, okay, so this would basically be 192.168.1.1, 1.2, 1.3, whatsoever. So these are internal private IPs, but these are external public IPs. So these IPs cannot be the same. These IPs will change. Okay, it has to be unique. And this static IP provision is done by your ISP service provider. He would be having something called a DHCP server, and he would be communicating with these routers. And from your ISP, they will again connect to your internet. That means ISPs has all the connections to the main. I mean, they have a sequence of ISP connection, so everything will directly first hit the ISP and then go. I hope this is clear. Okay. Now,
Yes.
now you need to understand what is a private IP space. A private IP space is nothing but which starts with 10.0.0.0 to 10.255.255.255 scheme is basically a private IP space. Why this is a private IP space? Why not 8.8.8.8 is a private IP space? Actually, when internet is being created, people understood that it is imperative that there might be a requirement, okay, to have a private IP. Okay, that means every device can have these three private IPs. Okay, any internet network interface can have these three private IPs. Okay, because they just in the requirement sheet of the architecture of the internet service model, they actually understood that it's beneficial to have private IP spaces. So they gave basically three different types. So we call this as a class A private IP. So we're gonna discuss the classes soon, but do remember this. So class A and this is class B, okay, until 172.16.0.0, and this is class C, 192.168.0.0. Now, this private IP is basically used for what? For the devices to communicate with each other in the same network. Remember that. What do you mean by communication in the same network? Okay, imagine yourself, you have an internet futuristic home. Then your devices is not required to travel all over the world to come back to your router. Okay, your router will directly connect to your local devices, and these devices can talk each other internally. Okay, so when you just come in, a sensor will pop up. The sensor, that means this sensor is actually worked to trigger other devices. That means let's say a smart home is actually there, and you just came into your house in the smart home, and the sensor triggered. When the sensor triggered, immediately AC has been started, TV has been started, light has been dimmed, and if you have a very futuristic home, then your supper is also getting ready, hot water is getting ready. All these thing can be actually triggered from one function. That's why the private spacing actually helps, okay, to actually reduce a lot of overhead if you use a private IP spaces. So that's why most of the smart homes use a single router with maybe a class B address. It will have a lot of other routers in the network because the house is bigger, but in short, it's still using the private IP of class B. Now coming to the terminology, you need to understand what is a static IP, what is a dynamic IP, what is a public IP and private IP, and what is I think this four would be enough. Okay, so if you just say what is a static IP, okay, a static IP is something which has a permanent That means a fixed IP address for your router. You might be thinking, why? Don't worry, because this once the IP address is fixed, it means that you can run a server, and even though your server is down or again backup, the IP address won't change, which actually helps to maintain your domain naming server. Okay, so most of the servers they demand a static IP if they are running a DNS, if they are running a web application or serving some content over the internet, because you can't every time update your DNS name, and because this process takes time and DNS propagation requires minimum 24 hours to get propagated. So it's kind of a, let's say, very important requirement one has to understand. Now, okay, but you are not serving any kind of a server. Okay, you are okay with the 24 hours downtime. In such case, you can use a dynamic naming server. What we call this? These IPs addresses can change. So even if you are actually on your home network, you can observe. You can type in Google. One second. You can type in Google. What is my IP address? So this is a package. So a website will tell you simply if you click on here. So this is IPv6. Don't worry, it will get converted to IPv4 in the short. Just for wait a second. Yeah, this is my IP address. Okay. Now, if I switch off my router for 5 minutes and restart, this will change because currently I'm viewed normal any kind of a currently any kind of DNS naming DNS naming would be in dynamic mode for most of home networks. Okay, now I think that is clear. Now this is basically means what? Dynamic means of IP addressing scheme, and if you have a fixed IP address, then it is static. Now, what is a public and private? Anything except these three addresses are basically public, and the private. I mean, we have one more private, but we cannot discuss this soon. And anything that is the three particular networks, these are basically called private IP spacing. Now, coming to the classes, we already defined classes, right? We said there are classes. Let's see what are these classes. So, while creation of internet, the particular standard internet standard actually identify 5 different types of IP addressing. Okay, with some default subnet mask. The first address space is called class A. So class A starts with 0 to 127 with a default mask of 255, 255, 250. What is this 0 to 127? So you have 4 different like X dot, Y dot, Z dot, A or A dot, B dot, C dot, B. So we have basically 4 dots in IP addressing scheme, right? The first, okay, octet, we call it octet in basic terminology scheme. The first octet have basically 1 or zeros, right? So when you actually have all the octets, that will become 256. Okay, now only the first octet, if we are having any address space from 0 to 127, okay, with the default mask, the mask is default, okay, don't worry. So then you will actually belong to class A. What do you mean by class A address space? A class A address space will have 2 to the power of 8 plus 8 plus 8, 2 to the power of 24 hosts. So how many hosts? Let me just say 2 power Okay, that is something around how many hosts the network can contain. It can contain a minimum of how much? 16 lakhs. No, yeah, 16 lakhs 77,720 Now, this is not just network. It can also can contain almost 256 networks. It can contain 256 networks of each the capacity of these many hosts. What is network and a host? A network is nothing but so your router can capacity of your router to have these many viable address naming spaces. Availability of these many address spaces. So if you actually have a class A address, it means that you can build 256 lines of network with 16 lakhs of hosts. So this is the biggest line, okay? So imagine if you have this much bigger, the network requirement or bandwidth requirement would be so much bigger. So, but at that time, nobody imagined that Internet of Things. Everybody thought that it is scales very what you call this innovative project, but nobody is sure that this will pick it up. So that's why they actually divided it into 4 different classes, and cost of each address space is very, very high. So if you go for a class A address, you have to pay maybe millions. Now it is not available because I think Google had one class A address, Microsoft has one class A address, and that is required for whole. I mean, they didn't require to have any more, let's say, address spacing requirement apart from the class A. Okay, so that's how big the class A addresses are. Now, if you go to class B addresses, okay, the class B addresses, okay, starts from 128 to 191. So the first octet is already class A. The second octet, okay, we have 4 octets, dot, 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 dot. So each octet has 8, let's say, digits. Now, the second octet is called class B address. Now, class B address, okay, can have something, I think the range is somewhere. You see, this is a class A address, okay, because of only, so if you use this particular CIDR block, you can have these many networks. Now, if you go to home and go to your demo, this is the network we created yesterday. Let me just show you, okay, what is our address space. 10.1.0.0. So we are using this particular private IP. So each network, each account in Microsoft Azure will have the private IP spacing of. I mean, I created with the 10.1.0.0, but if you go forward, you can actually even go with 172 or 192. So it's up to you what kind of address spacing you want for your network. Okay, so we have class B. The class C actually starts with 192 to 223. Class D starts with 224.247. Class E starts with 248 to 255. When you say 0 to 127, that would be something like anything with 0 dot 0 dot 0 dot 02 127.0.0.0. This is class A. Same, if you start with 127, anything that is between 170, this is class B. Now, if this is how I'm actually trying to convey. Now, this is 157 currently what I'm having. So what kind of a class address I have? I'm having a class B address. That means my SP service provider is actually using a class B addresses. Now, if I go from class C, this one, sorry, class B is 191, class C 192 to 223. So I think I missed 191. Okay. So now class A is 192, 223, and class D, which are class D and E are not in use. They are for experimental purposes only, or can be used for some kind of research projects at Internet Authority. So 224 to 255, class D and E are not currently in use. And I hope this is clear now regarding IP address scheme, regarding IP understanding of what is called a private network and public network, or what are classes, why classes are different, and each class has a varied price. Class A is highly expensive, class B is slightly lesser, class C is slightly lesser than B. So these are the things that you also need to understand. You don't really need to understand the financial aspect of it, but you need to understand what is the main technical difference between a class A, class B, and class C. I hope this is clear. I explained you clear. If you have any doubts, it's time for you to ask me now. Any doubts, Richa? Go ahead.
No doubts.
Okay. Go ahead. Any doubts? Raghu?
Yeah, no, Abdul. So sorry, I joined on the middle of
Okay.
the class, so just I'm looking for this private and public IP address only.
Yeah, this is the main core requirement. If you understand this, this is good. Because now we are going into virtual networking in Azure. So now you have the basics, okay? Now, what we're going to discuss most examples. Okay, good. So if we understand yesterday we just discussed overall view of 4 different types of important components on Azure, which is virtual networks, storage account, and also virtual machines. Remember? So out of which today we're going to discuss virtual networks. Remember this, virtual networks are really an important aspect in the cloud, in Azure cloud or in AWS cloud. One has to understand how this basic mapping goes on inside a virtual network. Now, if you say this is our basic network infrastructure looks like this. The end customer, basically our users, they don't know how the infrastructure works. They have a DNS name, they click it, the application should work. That is their expectation. Now, you are an Azure DevOps. Now, your requirement would be, you need to know how to construct an application in a secured virtual network. For that, you need to know you need to understand what exactly happens inside a virtual network. Now, if you're coming to Azure Global Infrastructure, okay, inside any kind of a Azure account, okay, the first and foremost would be your subscription. Now, you have a subscription already available. Remember this. Now it's time for you to actually create a virtual network. So when you are creating a virtual network, you have to provide a subscription. Now you provided a subscription. Now you created a virtual network. Okay, by creating virtual network, everything should work. Is that is expected? No, it's not the same, because each virtual network can have multiple subnetworks. So a virtual network cannot run by default mode. You have to have a subnetwork. The first subnetwork, second subnetwork, third, fourth. What are these subnetworks? So when you say network, subnetworks, any networks inside this IP scheme. So currently we just discussed, okay, if you take any IPv4 address, we can have, I think, IPv4. So if you take any subnetting or calculator, you understand, okay? So if you take address space of 192.168.0.1, okay, net mask is 24, okay. Now you can see that how many, the network is 192.168.0.0, and the broadcast is this one. Don't worry about the broadcast and other stuff, but you need to understand that a network have an address. Each network has an address. Here, the address of my network is 192.168.0.0. Okay, you have to provide a subnet as well to identify this network. So this is your network. Now if I, instead of that, if I say 10.0.0.0, and subnet mask is 16, and if I calculate, then you see my net mask is 16. That becomes 16 is nothing but into the net mask of 255 into 255. Now the space is 10. Then what is my network? My network is 10.0.0 by 16. And don't worry about broadcast and unicast, but you need to understand the number of hosts I can have, okay, are 65534. Okay. Now if I take 10.1.0.0, now that will show how many? 65534. Now if I take 10 dot, but you see, I have to change this one. I forgot. If I take this one, this count, the number of host count will reduce. It's just 254. That means if I take 10.1.0.0, my network address space is 10.1.0.0. Now I can create one more network, 10.2.0.0. Again, in this network, I can have another 254 hosts. Likewise, I can have until the extent of it. How much? 255. So if I take 10.255.0.0, I can have another network. So how many networks I have? I can have 256 networks, each network with the capacity of 254 hosts. Now if you take my current address scheme of our current space, what is my address space? 10.1.0.0. I don't want this. Okay, let me just delete and recreate one. So I'm deleting this network. So I hope you understand what I'm actually stressing on. I'm stressing on identification of number of networks and number of hosts. Okay, now this is deleted. Let me refresh. Okay, Once you delete it, is gone. Okay, even if you click here, it's not going to show anything. Is that clear? Now let's create a virtual network. Okay, in this network, what I want to create 10.1. I want to create okay. Wait. Okay. Now I'm creating a new network. The subscription is same, and if you want the resource group, I want to go with. I have a resource group name network demo. I'm going with the resource group name, and okay, what is the resource I'm actually applying for this one? I'm going to say using a smart network. Now, if you go to IP4 scheming, here is the place where you need to add the space. So if you just say, if you go to default, it's gonna take the whole 10.0.0 space. But I want to have multiple networks, so I can't allow it to use only one network, but I can have now if you check, I can have 256 sub networks. So each network will have 256 hosts. That's good. I'm not going to create more than that in any space as well. Okay. Now I don't want to add any IPv6 address space. Okay, wait. I can take the space of 10.0.016 and I can add subnets. Wait, subnet name sub1. Here I can add 10.1.0.0. Okay. Okay, since I used 10 dot, okay, I'll use this one. What I'm doing wrong. Let's go with this one. 192.1.0.4. We'll add this bit later. First, let me clear. Now, the security is one of the most important. What kind of security you want to create? The bastion host security, I don't want to have it. The DDoS, not required. Firewall, I can enable it later. Okay. Now, tags are really important. Okay, it's better you create a tag. So why I'm creating this? Okay, so I can just write group or department. Education department. Okay. Now I'm just validation failed. Required information is missing. Okay, what exactly is failed? Okay, so okay, 192. Okay, I need to subnet them. It's 24 plus another 8, then becomes 8, 8, 16. Yeah, I can go with this one. No, not really. 16. Another 8. One, 24. Oh, come on, man. See, it does not look at 0 in the range. Hmm. 16 plus 4, 20. So this one. What the heck? Okay. I don't know why it is accepting. It's crazy. But maybe I'm doing something. Yeah. Mm-hmm. It's crazy. I don't know. This is making me difficult. It should be accepted, but it's not accepting it. Maybe I'm doing something wrong. Maybe this has some kind of a problem. Let me just add. It can't be out. This is the right one. Just don't know what exactly is going on. This is the address space. Why the subnet? You see, it's also showing the same 24. I'm doing the same, but it is not accepting it. Damn. I just don't know what exactly happened. I'm completely clueless. It's just showing me error till now and just accepted it. So I'm sorry guys, but I did try my best. So if you take this one, okay, I'll change it to 1 and take this one, change it to 1, still accept now. Okay. That's a weird result because it doesn't make sense. Anyway, let's stick with that for now. Okay. So I create a subnet, review, and let's now validation has been passed. So I'm just creating one. Okay. So my current deployment is ready. Okay. So my resource group. This is my resource group. Inside my resource group, I have a storage already. Now I have a network too. Let me just wait for network. Okay. Network demo is successful. So inside network demo, you have the small network which I just created now. Good. Now, we have another 5 more minutes. So if you just see, we have different subnetworks. Let me, okay, we have different subnetworks. So each subnetwork will be associated with a network security group. So if you just see, okay, there is a lot more properties and security as well. So this is a network security group. When you click in network security group, it's going to show you, okay, any subscriptions it has, and it has inbuilt security integrated with Microsoft. So Microsoft has Security Center. I hope you remember that. So it has inbuilt. Now each particular subnet can be actually have a multiple resources inside. Okay, subnet 1, subnet 2. So if we just keep on creating, I can create how many? Almost 256 subnets. Okay, so this is the first virtual network. So I can create in this virtual network. This is the subnet. So if you go to subnets, you want to go to, okay, you have a sub one. So if you go to subnetwork, then you're going to find any resources there. So this is your address range. And how many addresses you have? 251 addresses are available in this subnetwork, of which there is no NAT gateway available, there's no network security group available, no routing table created whatsoever, and there are no service points. This is, in short, the current status of your newly created subnetwork. Now, each subnetwork should actually, okay, so subnetwork, why basically we use networks? Because we want to flow data from internet to inside the servers. So, but we want to restrict how the flow of these particular data from internet to the subnet resources. Now, we need to have a network, okay, card, NIC1. We need to create one network identification card to actually pass the data to your firewall VM or your other subnets. So network cards are network interfaces are the way how you actually communicate between one subnet to the particular internet or other subnets. Okay, so if you want to do it, so this is, we can do it the console of your Azure. So Azure has something called console. If you click here, the sweet part with Azure is that immediately you will have a small window. The small window, okay, now you see, how do you want to go? You want to go here, or you want to go to PowerShell? Let me go with the bash. The subscription I want to use, of course, is custom. Now I'm creating a storage. So now it is initializing the cloud shell. Okay, that means you can work on the cloud directly from here on the command line. But for AWS, you don't have such facility. Now to see, this is my Azure. Now if you look my dummy account, yeah. So this is another dummy account I use. So so here, if I want to know what kind of virtual networks I have, okay. So you need to type, okay, AZ. Wait a second. Okay. AZ means Azure, okay, Azure. The second one is whatever the component you're working on. So currently I'm working on my network component. So network. So remember this, you need to learn this function. So this is the best method. Understand every command in a logical structure so that you can remember it faster. The first component is Azure. The second is network. Now, inside network, what exactly are we actually checking it? Virtual subnets, right? So virtual subnet has something called virtual and net, virtual nets. Second. and then list them down. Now this is called special options. Special options means if you want to list them, so if I don't give output table, I will get a JSON format. You see, but it's not readable because it's not helpful for me. So I want it in a readable format. So what do? Output. Now when I say table, it will get me a table format. That will easy for me to understand. Hey, I have a name of this network is small network, and the resource group is network demo, and number of subnets is only one, and the prefixes and any kind of other protections we have for this network. So I hope this is clear. Now, if you want to create one more subnet, okay, now this is the command you have to follow. Azure network, vnet, subnet, okay, create. We're going to anyway work on this tomorrow because today the time is up. So tomorrow we're going to completely look into hands-on part. So we're going to create this, but I'm just trying to explain the command. So you can also practice at your home if you have some time today. So Azure network, vnet, subnet, create. So you're creating what? You're creating a subnet. Global, G, virtual network, LRG, and here is the space where you can define your virtual network name. So vnet name virtual network 1 hyphen name subnet 2. Okay. So this network has something called subnet. Okay, and the name of the subnet is 2. So the current name is vnet 1. So whatever I worked on is the current subnet. Now if you check, let me just even show you this. Okay, take some more time. Azure. See, so I'm actually Azure network. Now the second component I'm using what? VNet. See, VNet is, don't confuse yourself with the particular space I written. VNet means it's just a command. Okay, virtual network means. Okay, now I got the VNet. Now you have to write subnet if you are actually creating a subnet. I'm creating a subnet. So I'm creating virtual network. Now I'm using subnet. Subnet create. Now I'm creating. Now this is one thing you need to understand. So this is a resource group. Okay, what group this particular contains? So what is my resource group? I have to write my resource group. Okay, I just written my resource group name. Now you are going to create subnet inside a resource group. Now it's time for you to mention the name of your subnet. How we can mention it? By using a special command, what? Hyphen vnet name. Because most of the time we are not going to use cloud UI, okay, because it's way faster if you use bash or PowerShell. It's way faster in comparison with it. Sometimes you can see that I had difficulties with, sometimes the right format as well, but every UI has some bugs, so we can't tell anything on that. So the virtual network name, what is the virtual network name I'm going to use? The same one. I'm just going to add subnet only. Small network. Now subnetwork is done. Now the name. What is the name of this particular subnet? Subnet. Okay. And then what kind of address prefix you want? So what is address prefix? So this is prefix. Okay. Now what is my? I think I have a subnet, right? What is the subnet address prefix? it has 10.0.0.024. Okay. So now fancy. Okay. So address prefix. Now it's time for me to put it down. 10. So how many hosts I can have in such config? I can have 251 hosts. Okay, you can check. This is from 1 to 255, of which 2 hosts will go for your particular Azure. So total 4 will go. So that's why you have 251. Now I'm actually creating one more. So it will become what? 10.0. So this is 0. Okay, 0 network. Now you will have one more. So this is 0. Then I have 10.0.1.24. So this should work. You see? Now you got a JSON. Some JSON created. Let's use the same command to list them down. Now you have 2. Okay, so if you check, the number of subnets are 2. Now you want to check, go there, you have subnet 2. Oh, sorry, I'm spelling mistake. But you can see it has the same specs. So this is how you can create a virtual network and create subnets from command line and also from UI. Now tomorrow we're going to discuss a bit more further. We're going to discuss. We already discussed subnets, by the way. So what are these subnets and what's the basic stuff? We just want to go and do a hands-on on adding a public IP, and that should mostly clear most of the hands-on on virtual networking. But we have something called network interface cards, NICs. We're gonna even add them. So this should actually clear the part of virtual networking for Azure. So make sure understand this. This is the most important part, by the way. So it's your so you really need to practice the same day that that I actually tell you, so that it's actually sticks into your brain. Otherwise, you will easily get confused. Networking part is the most difficult part and most interesting part as well. So make sure you practice it today. So that's all for today. I hope I took a bit more time than expected. I hope you don't mind. So let's catch up tomorrow. Bye-bye.
Thank you. Bye-bye.
Bye.